In the last video, we took inspiration from the ResNet paper to create a residual block. What this block did is process the audio through two convolutional layers, but in its output, it actually concatenates the original image as the first three channels, so the original image never gets lost. In this video, what we'll do is we'll use the residual block to create a monster variational autoencoder in just 15 lines of code. So with 15 lines of code, we're going to make an autoencoder with around 300 million parameters using our residual block. And then I'm going to show you how you can use that autoencoder to generate new images. So first off, we start by importing torch. We're going to import a utility function that I created that prints the number of parameters in the network we're going to create. I just find it very useful to add it to the init function to see how many parameters we have. We create and we import the created residual block. Next up, we're going to define the encoder and decoder channels. Since in any autoencoder, the channels progressively increase as the size is decreasing and decrease when the size is increasing, we're actually going to have fine-tuned control over the progression of the decrease and increase of the channels. And we're good to go. Let's get started with the really fun part. So first up, we're going to define the encoder class, which is an extension of the torch.nn.modules. We define the init function. So this is pretty much boilerplate PyTorch. The model itself is going to be sequential. It just goes one way. And we're just going to use an enumerate function to iterate over the channel list and ignore the last item in the channel list to add a residual block and a max pool block over the number of channel increases. At the end, we add two linear layers. This is going to be a variational autoencoder, so it's going to output not exactly a point, but rather a mean and standard deviation of a latent space as a variational autoencoder. So it's going to output two tensors. And that's pretty much it. In around 15 lines of code, we've created a 150 million parameter PyTorch model using just vanilla PyTorch. And this model is implemented with the ResNet style architecture, so it can get really big and really deep. Next up is creating the decoder. The decoder is going to take only one tensor that will be sampled from the latent distribution using the mu and log var outputted with the encoder. And the decoder is basically the same thing. It's the encoder coded about in the same way, but instead of upsampling, we'll be downsampling. So there you have it. Pretty simple and short, succinct code to create a really huge network. If you like this, follow along, because the next step will be creating the actual variational autoencoder with the two and training it with the elbow loss to generate new images.